In this section, we will be discussing the quotient rule and another couple of rules for exponents, and then we'll be dividing polynomials by a monomial. So for the first few, we're just going to look at what happens. So x to the fifth divided by x squared. Remember that x to the fifth means you're multiplying x by itself 5 times. And x to the second, or x squared, means you're multiplying x by itself 2 times. If you're multiplying, like let's say we have x divided by x, anything divided by itself is 1. These cancel out and leave ones in their places. So let's look at how many times we can cancel out x's here. These x's would divide out and leave ones. And then we'd have another pair of x's, one on top and one on bottom, that would cancel out and leave ones. And notice I've canceled all the x's on the bottom, so there's nothing else I could cancel any other x's from the top with. There are 3 x's left on top. So that means I could write that as x cubed. Look at the relationship between the exponents that I started with and the exponent that I have left. Let's look at another one before we draw our conclusion to see if it holds true again. So for number 2, we have y to the 6th. So I'm going to write out 6 y's. And on the bottom, I have y to the 4th. And I want to cancel out y's. So 1 y from the top can cancel out with 1 y from the bottom. And I'm going to keep doing that until I run out of y's to cancel. So remember, when I divide these out, they're leaving ones in their place, but anything times 1 is itself. Notice that I have 2 y's left, nothing left on the bottom, so I could write it like that, but anything over 1 is just itself, so I would just write y squared. Again, look at your exponents that you started with and look at the exponent that you have left. Okay, so if you could draw a conclusion, you might see that if you subtract the exponents that you started with, you get your answer exponent. So 5 minus 2 is 3. That's from example 1. Example 2, we have 6 minus 4 is 2. And that is, in fact, the rule that you could use. So this is equal to x to the 5 minus 2, which is x cubed. And this would be y to the 6 minus 4, which is y squared. So if I'm going to use that rule, I could use it for number 3. So let's see what happens if I do that. I would have m to the 3 minus 8, which is negative 5. Notice I'm always doing numerator minus denominator. Numerator minus denominator. Let's also look at this one like I did for number 1 and 2. This means I have to write out 8 m's on the bottom multiplied. Okay, let's see, did I get 8? I think so. And then on the top, I have 3 m's multiplied. I want to cancel out until I can't cancel anymore. So I've canceled all the m's from the top, and all that's left, remember, are 1's. So 1 times 1 times 1. And on the bottom, I have 5 m's left. So if I'm going to write this, on the top I have a 1, and on the bottom I have an m to the 5th. Notice that there were more m's on the bottom. 8 is bigger than 3. So if I wanted to write this with positive exponents, which actually is what I want to do, I would avoid using this rule because it's true. It does simplify to m to the negative 5th power, but it's not considered simplified until you move it and make it a positive exponent. So this is going to lead us to our 2 rules that we're going to look at. So if I look at the first rule, I have the quotient property for exponents. It's giving us the rule that we saw already. We can subtract the exponents and get our answer. The other side is telling us that if n is bigger, so if the denominator is bigger, you're going to leave it in the denominator and subtract, and you're going to keep it positive. So you're actually going to do denominator minus numerator. This helps you avoid negative exponents. If you use the first rule, that's fine, but then you have to remember the rule of negative exponents. Anytime you have a negative exponent, you can make it positive by moving it to the other side of the fraction. So right here we noticed that m to the negative fifth is the same as 1 over m to the fifth. So we would make it positive by moving it to the bottom. Another example might be if I had x to the negative third. Remember that you can write anything over 1. If the exponent is negative, you want to move it to the other side of the fraction in order to make it positive. So it would go to the bottom, and this would be 1 over x to the positive 3 power. Alternatively, if you started with a negative on the bottom, let's say 1 over y to the negative fifth, you could turn this into a positive exponent by moving it to the top. So this would be the same as y to the fifth over 1, or just y to the fifth. So anywhere you have a negative exponent, it becomes positive if you move it to the other side of the fraction. So if it started on the top as negative, it's going to be positive on the bottom. If it started on the bottom as negative, then it will be positive on the top. Okay, so number 4. Let's look at this. The way I suggest doing this is looking at where the most are and leaving it there positive. So for the r's, I have 9 on top and 3 on the bottom. So 9 is bigger than 3, so the r is going to stay on the top. And I would do 9 minus 3 is 6, so r to the 6th is on the top. For the t's, the exponent on top is understood to be a 1. 8 is bigger, so the t is going to end up on the bottom. And 8 minus 1 is 7, so t to the 7th is on the bottom. This is simplified because I've combined all my like variables. So all the r's are combined into one r, and the t's have been combined into one base t, and so that's all I can do. Okay, so just to point out again, to be considered simplified, all exponents should be positive. So let's simplify here. So z to the negative 4. It's not simplified because I have a negative exponent. So since this is currently in the numerator, in order to become positive, we would have to move that. So 1 over z to the positive 4 would be what I'm looking for here. Number 6, it's currently in the denominator negative, so to make it positive, I would move it up. So it would be n squared. The next rule we'll look at is the zero exponent property. Anything raised to the 0 power is 1. So a quick explanation would be, if I have x squared over x squared, would you agree that these cancel out and leave 1s? So that's just 1. You could also look at it using the quotient rule. So I could rewrite this as x to the 2 minus 2. 2 minus 2 is 0. So that means I got an answer of 1 and an answer of x to the 0. Those have to be the same. So anything to the 0 power is 1. And the reason is because really what that means, if it's to the 0 power, it means that you're dividing by itself. If you divide something by itself, you get 1. So anything to the 0 power is 1. So let's try to simplify these using that information. Number 7. Hopefully you see that the answer is 1. 5 to the 0 is 1. Number 8. This one is tricky. If you think this is 1, you made a mistake. The only thing raised to the 0 power here is the a, not the 3, because it's not in parentheses. So this means a to the 0 is 1. So this means you have 3 times 1, which is 3. So the answer to number 8 is 3. In order for this to be just 1, I would have had to write the 3a in parentheses. Now, if it had been written like that, then it would be 1. But since there aren't parentheses, the only thing raised to the 0 power is the a. Number 9, everything is the base. It's in parentheses. So this whole thing would just be 1. So number 7 is 1, number 9 is 1. Number 10, if you think this one is 1, you made a mistake here as well. The only thing raised to the 0 power is the 7, not the negative sign. So this would actually be -1. Again, if you wanted it to be 1, the -7 would have to be in parentheses. -7 in parentheses raised to the 0 power is 1. If you don't have parentheses, it's going to be -1. Okay, so a few more examples of simplifying, and then we'll really get to the division by a monomial. So for number 11, simplify 5a to the -7. Remember, you want to simplify by moving your negative exponents. Keep in mind here, the only thing raised to the -7 is the a, not the 5. So the only thing you're going to move is the a. So this is moving to the bottom, not the 5. So the 5 stays on top, and the a moves to the bottom and becomes a to the +7. And that's it. Number 12, both 7 and 3 are raised to the -2. So probably the easiest way to do this is just to flip the entire fraction. So this becomes 3/7 squared. So notice the exponent became positive when I flipped the entire fraction, and that's because the entire fraction was raised to a negative. So you just flip it. Then you're going to actually square it. So 3 squared is 9, 7 squared is 49, so 9/49 would be the simplified version of that. Number 13, we have 2 to the -3. So the first thing is to move the negative to the bottom. So this would be 1/2 cubed, and 2 cubed is 8. So we would simplify that as 1/8. Number 14, and again, I highly encourage you to pause the video, try these on your own, and then check. So everything that has a negative exponent, we're going to move. So 3 to the -2 would be moving down. And let's see, x to the -4 would be moving up. So we're going to have x to the +4 on top now, and 3 to the +2 on the bottom. 3 squared is 9, so we'll have x to the 4th over 9, and that's as far as we can take that. Okay, number 15. I have 15 and 30 as coefficients. You can reduce that just like you would a fraction. So 15 and 30 are both divisible by 15. So 15 divided by 15 is 1, and 30 divided by 15 is 2. So those would reduce in that way. I'm going to now move all of my negative exponents, and actually I only have one. So x to the -3 is going to move down, and I don't have any other exponents that are negative, so I'm not going to move anything else. So this is going to be 1 y to the 5th, that's all that's left on top, and on the bottom I have 2 x to the 4th y cubed times x cubed that moved from the top. Now what I want to do is look and see if I can combine any like bases. So I have two different bases of x. I have x to the 4th and I have x cubed. Notice that they're both on the bottom. So those are working together. So I'm just adding those exponents. So if they're on the same level, you're adding the exponents. If they're on different levels, that means they're working against each other. I have 5 y's on the top and 3 on the bottom. So 3 of those are going to cancel. So you're going to be subtracting the exponents there. Okay, so there are more y's on the top, so we would subtract 5 minus 3 and get 2. And since there are more on the top to begin with, that's where they will be left. On the bottom, I have a 2, and then I have x to the 4th times x cubed, and I'm going to add those exponents since they're both on the bottom, so I'll get x to the 7th. And that's as much as I can do. Number 16. So I would start by moving all my negative exponents. So I have y to the negative 2. That's going to move down. And then on the bottom, I have x to the 6th, or negative 6th, and y to the negative 5th. Both of those are going to be moving up. So let's move everything. So 3x stays on the top, and then x to the 6th would move to the top, and y to the 5th would be moved to the top. On the bottom, nothing stays, but I move a y to the negative 2 down to become a y to the positive 2. So now I need to combine any like bases. So on the top, I have my x's. They're both on the top, so I'm going to be adding those exponents. So that's going to give me 3x to the 7th. Remember that this is an understood 1. And then I might not need that. Let's look. The y's, I've got some on the top and some on the bottom. So since they're on opposite sides, I'm subtracting the exponents, and I want to leave it where the most were. So since there are more y's on the top, there are 5 on top and only 2 on the bottom, I'm going to be left with y cubed on the top as well. So there's nothing left on the bottom. So I don't have a fraction anymore. This is my answer. Number 17. I want to look and see what's negative so I can remember to move it. So I have m to the negative first. That's the only negative exponent I see. So that's going to be the only thing that I move. Also notice that my coefficients, 6 and 12, can reduce. So 6 divided by 6 is 1. 12 divided by 6 is 2. So let's see what I get. I will have n to the 4th left on the top, and that's all that's left on top. And then I have a 2, m to the 6th, n to the 9th left on the bottom, and then I moved an m to the negative 1 down, so it's going to become m to the positive 1. I don't have to write the exponent of 1, but if it helps, you can write it. And now I want to simplify by combining like bases. So again, my m's are both on the bottom. So since they're both on the same level, I will be adding the exponents. And the n's are on different levels, so I'll be subtracting those exponents and leaving it where the most were. Notice that there are more n's on the bottom, so the n is going to stay on the bottom, which means all the n's on the top will cancel out, and it will just leave me a 1 on top. So I'll have 2 m to the 7th. When I add 6 plus 1, I get 7. And then 9 minus 4 is 5, so n to the 5th. And that is my reduced fraction. Okay, number 18. This one looks terrible until you realize that everything in parentheses is the base and the exponent is 0. If everything is in parentheses and it's raised to 0, the answer is just 1. Okay, so let's look at the last 3. Here is the divide by a monomial part. So notice on the top we have more than one term. In number 19 we have 2 terms. In numbers 20 and 21 we have 3 terms. The key here is to remember that you're dividing each term by the denominator. So I highly encourage you to rewrite this in that way. So we have negative 24x to the 5th is the first term, and I want to divide that by 8x. And then I have plus 16x cubed, and I want to divide that by 8x. So I'm dividing each term. So the first fraction is from this. That's my first fraction. The second fraction is this. So I'm making each numerator, each term in the numerator, and I'm dividing it by the denominator. And then I'm going to reduce each fraction separately. So negative 24 divided by 8 is negative 3. X to the 5th over x to the 1st. Since there are more x's on top, I would be subtracting and I would get x to the 4th. And then 16 divided by 8 is 2. So plus 2. There are more x's on top. So I subtract x minus 3. 3 minus 1 is 2. So x squared. And so this would be it. This one is nice in that both of the numerator's terms divide evenly by that denominator. So I don't have a fraction left. That may not always happen. So number 20, we have 3 terms on the top. So we're going to have 3 fractions that we need to simplify. We have 35y to the 9th over negative 5y to the 7th. And then I have positive 10y to the 8th divided by negative 5y to the 7th. And then I have negative 5y to the 7th, divided by negative 5y to the 7th. So 35 divided by negative 5 is negative 7. There are more y's on top, so that will be y squared when I subtract. The second piece, 10 divided by negative 5 is negative 2. There are more y's on top. 8 minus 7 is 1, so I'll get y to the 1st, or I can just write y. And then the last piece, negative 5 divided by negative 5 is 1. And the y to the 7ths totally cancel, so that's just 1. So here is number 20. Remember that if something is divided by itself, it leaves a 1. So don't leave that part off thinking it's 0. It's a 1. All right, the last one, number 21. So we have 13z to the 5th over 3z squared. We have 15z cubed over 3z squared. And we have a negative 6z divided by 3z squared. So 13 divided by 3, well, that is not evenly divisible and it does not reduce. So we're going to end up with a fraction. So 13 over 3. And then there are more z's on the top. So 5 minus 2 is 3, and we leave it on the top. So we have 13z cubed over 3. 15 divided by 3 is 5, so we'll have plus 5. There are more z's on the top. When we subtract, we get 1, so that'll be 5z. And then negative 6 divided by 3 is negative 2. But here, there are more z's on the bottom. So I'm going to end up having a fraction. 2 is on the top, but z will be on the bottom. So negative 6 divided by 3 is 2. The 6 is larger, so the number, the 2, has to be on the top where the number is bigger. But for the z's, my exponent here is 1, and the exponent on the bottom is bigger. So the z has to end up on the bottom. 2 minus 1 is 1. So this is going to be my quotient when I divide this time. So it doesn't always have to divide evenly. It could end up being something like that. But as long as you've simplified as much as possible, that's what you're looking to do.